Hi everyone, I am here with Accenture coding problem. So I don't remember the year, but it was there in my collection. It might be like 2020 or 21 question. The question goes like this. Write code for the function int calculate sum int m int n. This function takes two positive integers m and n and returns the sum of all the numbers between m and n that are divisible by 3 and 5. This is the question. One function template is given and the name of the function is calculate sum. It takes two parameters and returns one integer. M and n are like range given and we have to find the sum of all the elements in that range m and n that are divisible by 3 and 5. That is the coding problem given. Sample input. If m is given in first line and n is given in second line. If m is 20 and n is 50, and what is the output? We should get 75. So how to understand this problem? So m is given as 20 and n is given as 50. We have to find the sum of all the elements in this range including 20 and 50 that are divisible by 3 and 5. So based on our common sense, we can simply assume that 3 and 5, the numbers that are divisible by 3 and 5 are like 15, 30, 45, etc. Let us, this 15 is below 20, we cannot consider that. After 20, what should we get? 30 is one number that is divisible by both 3 and 5. Then 45 is another number. Then another number could be 60, but that is above 50, we cannot consider that. So what are the numbers in this range that are divisible by 30 and 45? What are the numbers that are divisible by 3 and 5 in the range 20 and 50, 30 and 45. So the sum of these two numbers is 75. This should be the answer. Okay. So let us quickly write a code and I will also introduce you to the optimization of this approach. Optimization of the code when the range is high. For example, if n value, the difference between m and n is very high, how to deal with that case? That we will be seeing. Okay. Let me take online compiler. I will define a function def. Name of the function is calculate sum. It takes two parameters m and n. Okay. Now what I will do is, this is direct approach for I in range m comma n. So as we have to include n also, we should consider this as n plus 1. Now I should initialize sum to 0, sum equal to 0. Then sum is sum plus I. What is this I? This I should be like if I is divisible by 3 and I is divisible by 5. Then we will consider such I for summation. That's all. Return sum. In driver code, what would I write? I will read m value. As they have mentioned, they are integers. We have to convert that to integer. N is int input. Now we have got both m and n values. Now let us call the function print calculate sum m comma n. M comma n. That's all. Let us run this code. let me give the first value as 20, second value as 50. We got 75. Okay, it is successfully running. No issues with this. My concern is, suppose m is given as 1 and n is given as 1 lakh, that is 10 power 5. It is quite possible. In the constraints, they will give the possible values for m and n. Okay, so if m is given as 1 and n is given as 10 power 5, that is 1 lakh, how can we do this one? If you run this code, it will take 1 lakh number of iterations. It will take 1 lakh number of iterations. So is there any possibility to reduce the number of iterations? Yes, we can optimize this code further by considering LCM concept here. So what is LCM? Least common multiple. Okay, so I will be considering LCM of 3 and 5. So the LCM of 3 and 5 in this case is 15. Then I will be incrementing the values by 15, 15 and so on. Then we can reduce the number of iterations drastically. Okay. Now the concern is, shall I consider 15 in this case? Yes, of course, for this problem, as they have mentioned divisible by 3 and 5, I can directly consider 15. Suppose if they give some dynamic values for this in place of 3 and 5, we should be ready to handle that. So for that reason, I will be finding the LCM of 3 and 5 separately. Okay. So for that reason, I will be using GCD function from math module of Python. Import math. First I will consider LCM. LCM equal to, the relationship between LCM and GCD is LCM is equal to product of two numbers divided by GCD of its numbers. How can we find the GCD? In Python we need not write separate code, we can use the built-in function. Okay, so that is my idea here. Let me consider 3 multiplied by 5 divided by math dot GCD of 3, 5. Though we know the LCM of 3 and 5, why am I calculating this? Suppose in the problem, if they give some values, some variables for 3 and 5, we should be ready to handle that. Suppose if they give AB, that are divisible by A and B. So in place of 3 you can put A, in place of 5 you can put B, and you can get the things done. Okay, so for that reason I am explaining this. Now, how to optimize this code? Instead of running all the iterations, how would I do this is, if I is divisible by both 3 and 5, then I will capture that position and then break. Okay, next what I will do is, I will run another for loop, like for I in range. I will proceed from this position. Now I know from where the actual numbers that are divisible by both 3 and 5 start from. Okay, position, and I will take n plus 1 as usual. In place of step value, I will take LCM. Here in this case, for 3 and 5, LCM is 15, and the iterations will be 15 iterations will be skipped every time. Okay, now sum equal to sum plus I. That's all. Return sum. Now let us run this code. 20, 50, sorry, 20, 50. Oh, we are getting 50y. Position n plus 1 LCM. Sum equal to 0. Okay. Let me run this again. 20, 50, 75. Yeah, we got it. Okay. Now let me run the same code again for m value 1 and n value 1 lakh. 5 zeros. Yes, this is the value we should get. Now you may get a doubt. What is the difference between direct approach and this efficient approach? So let us track this count. I will take count equal to 0. In for loop I will put count equal to count plus 1, and here also I will put count equal to count plus 1. Okay. Now I will print count before I return sum. Got it? Run. Let me give m value 1, n value 1 lakh. You see the count. Instead of 1 lakh iterations, we have run the code, or we have achieved the result within 6681 number of iterations. Okay, so in the coding tests given by companies, there will be some test cases that will be checking for the efficiency of the code also. 1 or 2 test cases may be designed to check the efficiency of the code. They will check time complexity of the code or space complexity of the code. In such cases, you should act wisely. Okay, some people normally complain that some hidden cases were failed. For example, say if 12 or 13 cases test cases are given, 2 test cases failed, rest all I have cleared, like that they will say. So though their code is correct, those 2 test cases may be failed due to some edge cases or time complexity issues. Okay, so it is always better to write optimized code, even though if it is service based company's question. Okay, so I hope you liked this code. So if you want to capture this code, you please pause the video and then have the code, try it for yourself, and then comment if you like the coding question. Okay, so thank you.